So in order for firms to know, what prices they can charge and how much to produce, they need to know what consumers will buy, right? In order to think about that, we use something called the demand curve. And so the demand curve just gives the amount that consumers will buy in units, right? So that's our horizontal axis, quantity Q, and the price on the vertical axis, right? So price in terms of dollars or euros or yen or whatever. And we can think of this as their willingness to pay, right? Sort of the total willingness to pay of the market at different prices. And the law of demand says that as price increases, right? So as we move up the vertical axis, consumers will want to buy less. And that's almost always true for almost all products. Um, and so, for example, if the price is, here at, 3,600 or whatever it is at point A, then they will buy 60. If the price is up here at 6,000, then they're only going to buy, 23 or something. If the price falls all the way down to 1,800, then they'll buy 80. Now, in theory, firms can try to figure out their demand curve based on different prices. Um, Larger firms will have a much better idea of their demand curve, often because they'll do experiments. They'll increase the price, they'll decrease the price, they'll see how their demand changes. Other firms may have less of an idea, and so they may be less willing to, change the price because they're worried that it will hurt them. And also, of course, for some firms, the relationship they have with their customers is very important. And so they may worry that if they increase prices with no justification, that they will lose those customers. And so firms have to worry about all of these things in real life. In our example here, the demand curve shows the market's willingness to pay. And so the firm can sort of choose any point along this demand curve that will maximize their profits. Now, obviously, what they can't do is say, "Oh, okay, I want to charge $6,000 and sell 100," right? Because if they charge $6,000, there aren't enough consumers out there that are willing to pay that price to sell 100 units, right? They'll only sell maybe 23 units, and so they are constrained by their demand curve. And so the way we can sort of figure out what they're going to do is by looking at profit. And so profit is revenue minus costs, right? Whether you're an economist or an accountant. When you're an economist, you think about total costs. And so that includes things like the opportunity cost of capital. What could we be doing with this capital besides, in this case, making cars? And so our economic profit is total revenue minus total costs. And so one way that we can think about profit is by drawing these isoprofit curves. And so isoprofit curves give you the combination of quantity and price that give you the same profit. Remember, iso means same. And so, if we look at, this bottom curve that goes through point B, that gives us our zero economic profit curve, right? That's our average cost curve. Basically says, okay, we don't make any profit. All of these combinations, whether we charge 6,000 or we charge 4,000, but that's basically going to give us zero profit because our revenue and our costs will just be the same. But if we are able to increase our price, then, if we can get, for instance, on this isoprofit curve, then all of these combinations of quantity and price will give us a profit of 70,000. And so whether we're at point G or whether we're at point K, our profit is the same. Or if we can charge an even higher price, then we can get an ISO profit curve of 150,000. So we're at the point H, for example, or if we are, over here charging a higher price but selling less. Now, obviously, just like with indifference curves, when we were talking about people, you want to be on a higher ISO profit curve if you are a firm, right? But just like with people who are constrained by their choice set, firms are constrained by their demand curve. And so what firms will do is choose the point on the isoprofit curve that is just tangent to the demand curve. So in this case, we would be at point E. That will maximize profits and be equal to 63,360. And so this is a constrained optimization problem, just like with the consumers that we did in Unit 3. And just like with them, there's lots of ways to solve this problem using math. We're taking the sort of somewhat easier way out and using just a graphical representation of the problem. Um, but for example, firms might like to be at some point here where they would get even more profit, but that's not in their feasible set, right? Because they're constrained by their demand curve. And if they were producing someplace on a lower isoprofit curve, they could increase price and quantity until they get to point E, right? And so we can think of, firms' behavior as even if they don't exactly know their demand curve and their isoprofit curves, they keep experimenting with price and quantity. How much can we sell at this price? How much can we sell at that price? Until they maximize their profit. And they get to point E, they might say, oh, maybe we can increase price a little bit. Oh, no, we didn't sell those. And so we go back to point E. And so we can think of this again as a point where those two slopes are equal, where the marginal rate of substitution is equal to the marginal rate of transformation, right? Basically, all we're saying when we say MRS equals MRT is that those two slopes are equal. They're just touching. So where is the point where firms actually maximize their profit? Well, the answer is that it's going to be where marginal revenue is equal to marginal cost. Now, marginal revenue is how much more revenue you get from selling an additional unit. Now remember, because we have a downward sloping demand curve, the only way that you can sell an additional unit is by dropping the price, right? And because of all those units are sold at the same price, that marginal revenue is falling. And so our marginal revenue curve is downward sloping. And we said in our example, we're assuming our marginal cost curve is upward sloping. Sometimes you'll see a marginal cost curve that's downward sloping and then upward sloping. But either way, there's going to be some point here at point E where the marginal cost is equal to the marginal revenue. And so what's special at that point? Well, if you're at point B, right, and marginal revenue is higher than marginal cost, then you want to keep selling because when you sell an additional unit, the revenue you get is higher than the cost you have to pay. And so profit goes up. And that is true all the way to point E, where marginal revenue is just equal to marginal cost. If you produce another unit after point E, for instance, if you produce at point C, then the revenue you get from selling those additional units is lower than the cost, and so profit goes down, right? And so to the left of point E, profit is going up as you produce more, right? So that's what this curve here is saying. Profit is going up, 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 up. But then at point E, if you produce any more, profit is going back down. And so you want to produce right here at the top of the hill where profit is maximized.